All right, Algebra 2, Lesson 44, rationalizing denominators. I think we've already talked about part of this, where if we had a radical in the denominator, especially if it was a square root, we would multiply by that square root top and bottom in the numerator and in the denominator, right? Because it's equivalent to 1, and it would basically, let's say we have like 2 over square root of 2. If I multiply by square root of 2 over square root of 2, in the bottom, square root of 2 times square root of 2 is square root of 4. Square root of 4 is equal to 2. So it gets me a nice, neat whole number in that denominator, right? Yes? Yeah. Right? And so on the top, I'd get 2 square root of 2 over 2. The 2's cancel out. I'm just left with square root of 2 for my answer, right? But when you've been doing this a long time, you can kind of do all that in your head, right? Today we're going to talk about rationalizing more complex radical denominators, things that are a little bit more irrational. So the expression's 3 over 2 radical 5, right? This is irrational, right? It's got a radical 5 in the denominator. I can't have that there. We could also have something like 4 over radical 3 over 2 minus 3 radical 3. Those have irrational denominators because both radical 5 and radical 3, right? Radical 5 here, and radical 3 here are irrational. I can't have those there, right? If you ever leave an answer with a radical in the denominator of a fraction, it is automatically at least half wrong, okay? And I say half wrong, meaning that if you're in Algebra 3, it's going to be half wrong, okay? In this class, it's going to be all wrong, right? Because I don't do half points on tests, okay? So, to rationalize the denominator of an expression, we write an equivalent expression. An equivalent expression means something that is equal to 1. So that's why I'm multiplying by something in the numerator and the denominator that is exactly the same. Okay, equivalent to 1. That's what we mean by an equivalent expression. Does that make sense? Because if I multiply by 1, have I changed the value? No. So I'm writing an equivalent expression, something that's equivalent to 1, so that it changes the form of my fraction, but doesn't change the value of the fraction. Do we understand that? Okay, good. All right. So we write an equivalent expression so that there are no radicals in any denominator and no denominators in any radical. An expression containing square root radicals is in simplest form when there's no radicand, when no radicand has a perfect square root factor, and there are no irrational radical expressions in any denominator. All kind of complicated. But we're going to learn how to deal with some of these more complex situations. So to rationalize some binomial denominators, meaning that there's 2 terms in that denominator where a radical is included, we need to multiply by a conjugate. Sometimes we run into mathematical terms that we're not familiar with. Conjugate is one of those, right? How many of you are familiar with that? You know what I'm talking about? Nobody in here. Okay. All right, so this is where you want to pipe up and pay attention. Okay, take notes, do whatever, because if I'm learning a new term, right, I'm going to be more likely to forget this later on because it's completely new to me. All right, so let's say that we have a terminology here where we've got A, B, C, and D are rational numbers, right? They're numbers that make sense, like 1, 2, and 3. But we have something like A square root of B plus C square root of D, all right? What we are saying is that this right here, A square root of B plus C square root of D, and A square root of B minus C square root of D are conjugates. What's the only difference between those 2 things? The plus and the minus, okay? The plus and the minus. So all that we are doing when we multiply by the conjugate of something is multiplying it. Now this is binomials, right? So there's 2 terms. All I'm doing is multiplying by the exact same thing with a different operation, with the opposite operation on the inside. And this is done only with addition and subtraction. Does that make sense? Okay? They are conjugates of each other. So if I say multiply by the conjugate, you're going to take the exact same thing, all right, but with the opposite operation in between them. So let's say for a second, we've got 2 over 3 plus radical 5, right? I can't leave it like that because it's got radical 5 in the denominator, so I'm going to multiply by the conjugate. What is the conjugate of 3 plus radical 5? 3 minus radical 5. So I'm going to multiply by 3 minus radical 5. Do I just multiply it by that there? What else? I have to also do it on the top. Okay? Because what is 3 minus radical 5 over 3 minus radical 5? What is that equivalent to? 1. So have I changed the value of it at all? Now, here's the really neat thing about the denominator of this. This will always happen every single time, right? This is FOIL, right? Okay? But there's a terminology for foiling when it's the exact same terms, but with an opposite sign in the middle. What do we call it? It's a sum difference, which means I only have to multiply 2 terms, right? Which ones? The first to the first and the last to the last, all right? So what I wind up with in a situation like this is 3 times 3, which is 9, and radical 5 times negative radical 5. Well, what's radical 5 times radical 5? Radical 25, which is 5. And so I have minus 5, right? Because a positive times a negative is a negative. So I get 9 minus 5, which is 4. And so I wind up with a nice, neat whole number. All right? Now in the top, I'm going to distribute the 2. So I'm in the top, I'm going to get 6 minus 2 radical 5, right? All right? And so in the end, what I would do with this is I would simplify those fractions. So 6 divided by 4, that's going to give me 3 halves, and 2 divided by 4 is going to give me 1 half, right? And I would simplify that on down. Does that make sense? So do we understand how conjugates work? Great. All right, so sometimes I think whenever we deal with just these letters, it gets lost on how it works. Okay, because A, B, C, and D, what are you even talking about? Give me some numbers so I can see a real, actual situation. Does that make sense? Okay, so if a denominator has the form A radical B plus C radical D, the conjugate of it is A radical B minus C radical D, and vice versa. So you multiply the numerator and the denominator. In this case, I would multiply, if I had this one here, right? I would multiply the numerator and the denominator by that, if this was the denominator. If this was my denominator, I'm going to multiply both the numerator and the denominator by that conjugate. Does that make sense? So if it's addition, I multiply by the conjugate with the subtraction. If it's subtraction, I multiply by the conjugate with the addition. We got this? It is not terribly, terribly hard, okay? But it is easily forgotten. Okay? All right, let's pull this out over here. All right, I want to multiply by the conjugate of this. What is the conjugate of radical 6 minus radical 5? Radical 6 plus radical 5, very good. Okay, so because I can't write on this, I'm going to come over here. All right, so this was 9 over radical 6. Was it plus or minus? Minus radical 5. And Diego told me I'm going to multiply by radical 6 plus radical 5 and over, radical 6 plus radical 5. All right, let's do our numerator first. What do I do with the numerator? John, what do I do with the numerator? Above the division bar. The calculator's not going to do it, man. You're right. Yes, go with that gut instinct. I'm going to distribute. All right, distribute what? Okay, what's 9 times radical 6? No, your calculator won't do it. Yeah. No. It's not 9 times 6. It's just 9 radical 6. Right? Don't make it more difficult. It's just 9 radical 6. It is the same thing at this point as saying, what is 9 times x plus y? What would you get? 9x plus 9y. So you're not going to get 9xy, right? Because they're separated by that addition. Okay? So what's the other term up here? I've distributed the 9 to the radical 6, and then I'm going to get what? Plus 9 radical 5, right? Okay, don't make that harder. Okay, and again, with these, your calculator's not going to do that, and it doesn't even really need to. All right? Allison, help me out here across the bottom. What do I do? What is that? It's radical 36, which is 6. So I know we talked about it when we were dealing with this earlier, but anytime I have a square root times the square root of the same value, it's just that number outside of the square root, right? Yeah. All right, so square root of 49 times square root of 49 is, I don't have to think about this whole second thing, okay? All right, then I have the next one, right? Which would be negative 5. All right, well, what's 9 minus 5? Or sorry, 6 minus 5. 1, right? So this just comes out to 1. Do I even need to list this here? No, so my answer just comes out simply as this right here. Do we feel like we understand this well enough? Perfect. All right, because that's all we have time for.